The sun isn't floating in empty space. It's plowing through a cosmic environment so extreme, scientists still can't fully explain what surrounds it. Here's what nobody tells you. The solar system isn't a random spinning blob floating in the middle of nowhere. It has an address, a precise position inside a massive galaxy. And when you ask what's above and below the sun, like directly perpendicular to the plane of the planets, the answer is one of the most haunting, gorgeous things in all of astronomy. But we're going to earn it. Because first, we need to break something. Here's the problem. When most people imagine the solar system, they picture something like a flat record. 8 planets spinning outward from the sun in a nice, neat disk. And that's kind of accurate, actually. The planets do orbit roughly in the same plane. Astronomers call it the ecliptic. So far, so good. But then ask someone, what's above that disk? And they'll usually shrug. Empty space, maybe? More stars? And technically, sure. But that answer completely misses what's actually there. Because the sun isn't just sitting still in neutral territory. It's moving fast. It's orbiting the center of the Milky Way at about 220 kilometers per second, dragging every planet with it. And as it does, it traces a path through a very specific neighborhood of the galaxy. That neighborhood has structure. It has layers. And the sun sits inside one of those layers like a marble resting inside a groove. That groove is called the galactic plane. Now that's where it gets interesting. The Milky Way, when you zoom way, way out, is a flattened spiral disk, like 2 fried eggs pressed back to back, if we're being honest. Most of the galaxy's stars, gas, and dust are concentrated in this thin band, the galactic plane. The sun sits roughly in the middle of that disk, not at the center of the galaxy. We're actually about 26,000 light-years out from the core, somewhere in a minor spiral arm called the Orion arm. But within the thickness of the disk, we're close to the middle, off by maybe 50 to 80 light-years toward what astronomers call the northern galactic hemisphere. So what's directly above and below the sun? Above, and I mean straight up, perpendicular to the galactic plane, lies the galactic north. In that direction, you're looking out of the dense, crowded galactic disk and into the vast, sparse, breathtaking emptiness of intergalactic space. The star density drops dramatically, the dust thins out, and eventually, you're looking at distant galaxies, the Virgo cluster, the Great Wall of Galaxies, structures so enormous they make our entire Milky Way look like a dust mote on a window. Below, toward galactic south, you get roughly the same picture. Another escape hatch from the disk, another window into the void between galaxies. We've all had that feeling, right? Standing on a rooftop at night, looking up at the stars, and feeling impossibly small, but also like you're standing at the edge of something. That feeling isn't just romantic. It's directionally accurate. When you look straight overhead in the right season, you genuinely are staring out of the galaxy and into the deep. But here's where it gets even stranger. The sun doesn't stay put in that mid-plane. It oscillates, up and down in slow, lazy waves, like a horse on a cosmic carousel, bobbing through the galactic disk over millions of years. Every approximately 33 million years or so, the sun dips into the denser regions of the disk, then floats back up through the midplane and out the other side. It's been doing this probably for the entire 4.6 billion years of our solar system's existence. That's roughly 140 of those cycles. 140 times the sun has passed through the galactic midplane. Now, some scientists have floated a wild hypothesis, and look, it's genuinely controversial, not everyone agrees, but the timing of those midplane crossings seems to roughly correlate with periods of elevated asteroid impacts and mass extinctions on Earth. The theory? As the sun dips into the denser galactic midplane, gravitational disturbances from passing star clusters or giant molecular clouds could jostle the outer edges of our solar system, the Oort cloud, sending comets raining inward. Is that why the dinosaurs died? Almost certainly not on its own. But the idea that our position above or below the galactic plane could be influencing life on Earth, that's not science fiction. That's a serious scientific conversation. The universe isn't just big, it's interconnected in ways that keep reaching down and touching us. Here's the practical, beautiful version of all of this. When the Milky Way is visible, that pale, luminous band stretched across a dark summer sky, you're looking sideways through the galactic disk. You're looking at the crowded neighborhood, edge on, billions of stars stacked behind each other. But when you look 90 degrees away from that band, when you look straight up or down relative to the galaxy, you're looking out, through the thinner parts of the disk, past the edge, into the intergalactic medium. the near vacuum between galaxies where the largest structures in the universe drift like slow, silent weather systems. In that direction, on a clear dark night, you can actually see other galaxies with the naked eye. The Andromeda Galaxy, 2.5 million light-years away, is visible as a faint smudge near the constellation Perseus. That smudge is not a star. It's a trillion stars. And it's in the direction you'd be looking if you were staring out of the galactic plane. That tiny, forgettable smudge is essentially what we look like from there. Think about that for a second. So, you pointed straight up earlier. Here's what you were pointing at. You were aiming slightly out of the Milky Way, toward the sparse, quiet edge of the galactic disk, and beyond it, toward a universe that doesn't care about up or down, but which has structured itself into something so vast and so layered that the position of our tiny sun inside it still echoes down into the history of life on this planet. That arrow from the thumbnail, the one that gets the big red X, it's not wrong because you can't go up. It's wrong because up dissolves the farther you go. Up becomes out. Out becomes away, and away leads somewhere that redefines the word far so completely that it no longer feels like a human concept. The solar system has a vertical, the galaxy has a plane, and we are, right now, slowly bobbing through it, somewhere between two crossings, between two extinctions or escapes, floating in a position that is anything but random. Next time you step outside at night, find the Milky Way. Then look away from it. 90 degrees perpendicular, that's the way out. And honestly, knowing it's there, that the exit is visible on a clear night, no telescope needed, makes the universe feel a little less like an accident. Subscribe to the channel. Every week, we publish fascinating videos about everything imaginable, from hidden mysteries and shocking discoveries to stories that will completely change the way you see the world. Don't miss the next one.